In the previous video, we were introduced to vectors. As a quick reminder, a vector is an arrow that has both a magnitude and a direction. So it's represented with an arrow. So for example, this right here is an arrow pointing to the right. The right is your direction, and your magnitude, which is just a fancy word for length, is 1, 2, 3. So it's very, very simple to find the magnitude and direction of a vector if it's simply pointing up, down, left, or right. But things get a little bit more complicated when you're pointing in a direction that's not up, down, left, or right, some combination of those. Well, what we can do to kind of get around that is we can break it into what's called its components. So the x component is how far left or right you travel to go from the initial point to the terminal point. So the initial point is going to be at the tail of this vector. We travel 1, 2, 3 units to the right in order to get to the tail, the head. And we travel 1, 2, 3, 4 units up to go from the tail to the head. So if you look at this, we've actually created a right triangle where one leg is 3, one leg is 4, and the vector itself makes up the hypotenuse of this triangle. So if we want to figure out the length of our hypotenuse, we're going to end up using Pythagorean theorem, where our leg lengths are the x component squared plus the y component squared will give you the vector. Now in math we end up using the absolute value symbol to represent magnitude. You might also see it represented as the double absolute value, or you'll see a couple other things as you go through. But if you end up seeing the absolute value of v, and v is a vector, you know you're looking for the magnitude. Now I did leave off that these should be squared, because remember Pythagorean theorem is a squared plus b squared equals c squared. So if we really want to have an equation just for the magnitude, we should take the square root of both sides. Now keep in mind, every time you take the square root of something, you should end up with plus or minus. But since this represents the length of something, we always just leave it as positive. You would never say that your desk is negative 2 feet long or anything like that. We always represent length with a positive number. So in this case, my x component, or how far left or right we're moving, is going to be 3. My y component, or how far up or down we travel, is going to be 4. And if you remember your Pythagorean triplets, or you go ahead and figure out what this is, you're going to find out that the magnitude of your vector, or the length of your vector, is 5. So I can confidently go ahead and put on my page that the magnitude of my vector is 5 units. But that only tells us about half the vector. We also need to know the direction of the vector. And just saying up and to the right isn't going to be enough information, because I can draw infinite number of arrows that point up and to the right. There's up and to the right, there's up and to the right, there's up and to the right. All of these vectors point up and to the right. So if we want to make sure to be specific with these things, we need to make sure that we tell our reader or our grader or anything like that, we need to tell them exactly which up and to the right we mean. And the best way to do that is by defining it as an angle. So when we want to give the direction of a vector, we should use angle. And the cool thing about putting it into a right triangle is that because it's a right triangle, we can use SOHCAHTOA. Now we know all 3 legs of this triangle, all 3 sides of this triangle. So really we could use any trig function that we want. Sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, tangent is equal to opposite over adjacent. So according to this angle right here, this is going to be our opposite side, this is going to be our adjacent side, and this is going to be our hypotenuse. Now again, we can use any trig function we want, but there's one that's better than the others. Not simply because it's better in general, but because we were given information about this. We calculated that the magnitude was 5. But we were given that the legs were 3 and 4. So when in doubt, I'll always use what's given to me rather than what I personally calculated. So which trig function uses the adjacent and the opposite? Well, that's tangent. The tangent of theta is equal to opposite over adjacent. So in our case, the tangent of theta is equal to the y component over the x component. If I want to solve for theta, I need to make sure to perform the opposite operation. A lot of my students end up saying, well, let's divide by tangent. But tangent is an operator. You can't divide by tangent just like you can't divide by the square root. So in order to get rid of this tangent, we do the arctan. It's also known as the inverse tangent, but either one will work out just fine. They are the exact same operator, just got a different name to them. So arctan of y over x. So let's go ahead and plug in our numbers. Theta is equal to the arctan of y component, which is 4, over x component, which is 3. When I plug this into my calculator, we're most comfortable with degrees. So I'm going to go ahead and make sure that my calculator is in degree mode. And when I plug that in, I end up with an angle of 53.130 degrees. So I can now tell whoever's looking at this vector, or whoever wants to know about this vector, that I have a magnitude of 5 units and a direction of 53.130 degrees. Now I will say that this only works for things that are pointing into that first quadrant. So if something's pointing up and to the right, it's pointing towards the first quadrant, which means that this is the only way that it works for that direction. In a later video, I'll show you how to modify it so it works for any vector, but you do have to do a little bit of thinking. So just as a quick recap for you guys, when you're looking at vectors, you can break it into the x component and the y component. The x component is how far to the right you go. The y component is how far up you go. And if you always go to the right and then up, then you can make sure that you can use that Pythagorean theorem, because now you've got a right triangle, to figure out that magnitude. Remember, magnitude is just the fancy word for length. Then when you want to find the direction, you can use any of the trig functions if you have the magnitude. But again, I would always personally prefer that you guys use the ones that are given to you, as opposed to ones that you figured out, just in case you made a little slip up. So 99 times out of 100, you're looking at tangent of theta. Do a little bit of algebra to rearrange this stuff, plug it into your calculator and be sure you're in the correct mode, whether it be degrees or radians, and then you can confidently give your magnitude of 5 units and your direction of 53.130.